So section 3.5, and we're dealing with quadratic inequalities. Now, the very best bit of advice I can give you is very, very simple, and so many students I've had don't follow it and then get questions wrong. Anytime you've got a quadratic inequality, sketch a graph. That's all you've got to do, and you will get the questions right almost all the time. And it's so easy to not bother, because it feels as though, after a bit of practice, you probably don't need the graph, right? And trust me, by the time you get to the exam, when you're seeing this and you haven't seen it for a while, when it's out of context, if you get into the habit of missing out drawing the graphs or sketching the graphs, you'll get it wrong sometimes. So if you're getting it wrong 2 times out of 10, well, that's going to make a difference if you're in the exam, isn't it? You know, you don't want an 80% hit rate on something that you're able to do. You want to be able to do it 100% of the time. And the difference, by the time you practice everything else, is just going to be in sketching the graph. So let's quickly have a look at this. 3 minus 5x minus 2x squared, and we want to know when that expression is less than 0. So the way we deal with this is we think of, first of all, a function, f of x equals 3 minus 5x minus 2x squared, and I draw that function. It's got a negative x squared, so it's an upside down parabola, and if you look in the blue box on page 49, we find that the solutions to the equation 0 equals 3 minus 5x minus 2x squared. The solutions to that equation are minus 3 and a half, and my graph's a little bit wonky there, but that doesn't matter really. It is a sketch of the graph. All you really need is whether it's an N shape or a U shape, and that it crosses the x-axis at 2 places or 1 place or no places. That's all we really need on the sketch, but the sketch is going to help. So in order to solve this inequality, we take that expression, we turn it into a function by putting it equal to f of x, and we try and sketch it. In order to sketch it, we need to know where it crosses the x-axis. It crosses the x-axis at the solutions of this equation, which are also called the roots of the function. All of that vocabulary is quite important. Understanding the difference between this and this and this, and not getting them all confused. They all have the same quadratic expression, but this is an inequality, this is a function, this is an equation, okay? And understanding the links and the differences is key, I think. So, this function crosses the x-axis at these 2 points, so that's what's important, and we want to know when that expression is less than 0. So that expression is less than 0 is just when is this function below the x-axis. So in other words, we want this part here and this part here. So do we? And the answer is always going to be, do you want the lump or do you want the sticks? Okay, the quadratic has got a lump on one side of the axis and sticks on the other side. In this case, we want the sticks. Now there's 2 separate parts, so we need 2 separate inequalities. Okay. This is a strict inequality, is an exclusive inequality. So these are exclusive inequalities in my answer. Okay. Not much more to say. I suppose you could get into the habit of putting a circle here and not colouring it in if it's an exclusive inequality, colouring it in if it's an inclusive inequality, so that you don't mess up at the end here. But I don't, really the key is draw the graph and think, do you want the lump or do you want the sticks? Let's just quickly do another one as well. So if we've got 12 plus 4x is greater than x squared, and again I'm taking this from example 10, well, if we want the solutions to that inequality, we're going to have to solve either this one, so bringing the x squared over the same side, or what they've done in the book is they've done it the other way around, and they've said 0 is greater than x squared minus 4x minus 12. So either this one or this one, they're both equivalent to the top one. If I draw the function which is related to this inequality, i.e. if I draw the function f of x equals x squared minus 4x minus 12, I'm going to get an upright quadratic. And in this case, I want the 0 is greater than this, so in other words, x squared minus 4x minus 12 needs to be less than 0. When it's less than 0, it's less than 0 below the x-axis at this bit down here. So in this case, I don't want the sticks, I do want the lumpy bit. And that is one part of the graph, it's one part of the number line, so I can express the answer in one inequality like that. And where do the minus 2 and the 6 come from? Well, they come from solving the equation x squared minus 4x minus 12 equals 0. The solutions to that equation are the roots of this function. The roots of this function are where the function crosses the x-axis. So it crosses the x-axis at minus 2 and 6. And So the lump that I want is from -2 up to 6, x is in between. It's an exclusive inequality because this is an exclusive inequality symbol here. And obviously, just in case it's worrying you, we solve that equation using quadratic techniques. It's on page 49 if you want the details. I don't expect you to be able to look at that equation and then see that -2 and 6 are its solutions straight away. You'd have to do some more work in between. That's section 3.5.